Nearly every shot of espresso these days is built on this one part, and no one stinking talks about it. And chances are, if you have heard of it, you really don't understand what it does or why it does it. This is a solenoid valve, which is a very simple electromagnet that decides if water goes through your machine or not through your machine, or doesn't stop going through your machine, or leaks everywhere. So it's a little bit important. My name is Bryce Himmelreich. I roast, fix, and brew specialty coffee for a living in our coffee shop and coffee roastery. Today, I want to show you this one piece from the inside out, because no one appreciates it until it breaks. And for that, we're going to go Chris Fix style over to my workbench. Now, real quick, if you like these technical dives into espresso machines, or you like luxury coffee design, feel free to sign up at the email list down below if I have set that up already. I'm providing 60 seconds of free value for people who are serious about setting up their own coffee bar at home, service their machines, or use it in a commercial setting. Anyway, back to solenoids. All right, before I explain how solenoids work, let me show you the internals of it. So I ended up ripping this one apart already. And for any of you out there who are watching this struggling to get theirs open, let me show you how I ended up separating. Because what ends up happening, you have your solenoid nucleus recessed in there, and then this guy is screwed on. This is our electromagnet or solenoid coil, and that seats on top, and then you have some weights on. Getting this guy off, usually pretty easy. You're going to try to get this stupid thing off, and you're going to struggle, and you're going to worry about stripping it. I'm not going to tell you exactly how I do it, but often it involves a vise and this guy. Just being real, you can yell at me in the comment section for that, but guess what? That's pretty efficient if you ask me, especially whenever there's any kind of calcium buildup. Yeah, you can get mad. I don't care. Whatever. Deal with it. So before I doodle, I just want to show the on-off state. What we're trying to do is make a seal, and you can see that this is an older one that's a little bit dirty. You're trying to make a seal with this nucleus against that little guy there, the little hole right there in the center. You can see where they've been mating up over the years. And if I can properly press that into the hole, then there's no water flow. And if I lift it out, now there's water flow through it, and we're trying to get water through the channel, into the hole, and out the other side. It's a pretty simple concept. So let me doodle this for you just so you can see it. We're going to have an off state, which is your normal. So you have no power going to this coil right now. And I'm going to show you how to test these coils in a second. You have an on state. And then to draw the inside here, let's do this. You end up having some kind of little seal in that kind of shape, and then an outlet. This is all your water inlet, and this is your water outlet. For the off state, this spring is now pushing all the way down on that outlet. And hopefully you can see that there. And for the on state, what's happening is we're actually taking this and we're using a magnet to pull that up, and now water can go through the system. So off state, that solenoid coil, the nucleus there, is all the way pressed down. Water's trying to come in, and it ends up hitting, and it can't move anymore. Sometimes you can have it go in the reverse direction. It just depends. For the on state, that magnet has now pulled that solenoid nucleus upwards, so it's now moved up rather than being face down, and you can have water run through, up, over, and through the channel. That's the simple way. On this side, you get no water through, and on this side, you do. So this is our on state. Important to know, and why I love solenoid coils so much, is if it fails and we can't get power to the solenoid, or something happens and your controller breaks, it's not going to sit there and stay on. This only happens if you have a bunch of debris, but normally it fails in the right direction. These things are awesome. Now this configuration is simply for a two-way valve. I'm going to show you a three-way valve now, which is what you normally end up having in your group head. You can see you still have a water channel 1, which is attempting to go through here, but you also have this outlet up here where you could have water going out. The way this works, if I were to have it off, that solenoid coil is now completely blocking down here, but it's not blocking the channel backwards. And this is how you get a backflush. So you pressurize the whole system by turning it to the on state, where it now seals up on the top here. So now you can't get any water through there, but you can get water through the normal channel, and this is normally your group head. And now whenever the shot's done, I turn it off. This thing now moves down, it seals up here. Now the water inlet is completely clogged and you can't get anything there. What you can get is all the pressure, because this is now up to 9 bar in that group head. It can now flow backwards out through here, and normally this is your backflush into your drip tray. But it's a fairly simple design for the 2-way and the 3-way. They both function the exact same. The only difference is this guide would be is instead of up here you have a cap, you would have an outlet valve, and this Nucleus would slide all the way up and made up at the top and completely seal that. Just a quick pointer for everyone: if you are trying to diagnose if your solenoid is in fact the problem, I want you to listen for this click. You're going to hear a pump hum, but also a click sound. Click, click. Not the button. Listen to the pump going for a minute. Get used to what that sound is, the pump. But then there is a little clicking sound whenever I turn this off that isn't the button. And then I click again when I turn it on that isn't the button. If you do not hear the click, click, click again, then your solenoid valve most likely is not functioning properly and it is not actuating that nucleus inside. The sound of that click is actually the nucleus slapping the inside of the nucleus guide. And so if you don't hear click, you're not getting any movement. All right, let's talk about troubleshooting these things. This is a 120 volt solenoid, and this is actually a 24 volt solenoid. And I know that this one is burnt out. So there is a few ways that these things can break. Point one is actually, this is a good example. If you get a bunch of crap down on that seal there, and it won't actually mate properly, and then you can end up getting a leak through the solenoid whenever you're not supposed to. So it won't fully shut off. In my opinion, that is the worst way one of these fails, because you cannot stop the water flow. If you have a bunch of leaking through a group head or water under your machine, there's a decent chance what has happened is you got a bunch of calcium buildup or scale buildup or whatever that is in there, or even just debris, and now it's trying to go down and mate, but you know, it kind of goes cockeyed and you can still see you have a flow path there. So failure point number one is simply debris, and this is for a bad seal. If you are constantly getting dripping, it is likely debris causing a bad seal. Number two is a burnt coil. So like I said, I know that this one's bad. There's two ways that these things tend to fail. For these 3-prongs, sometimes they're 2-prong, but for ones with 3 prongs, what I'm really worried about is the 2 prongs in parallel. I'm not so much worried about this. This is a chassis ground, and I mean, you can see how messed up this solenoid coil got. So what we're going to do is I'm going to take a multimeter, and I have it set to 2K resistance, and I want to make sure that I have some readable resistance across these 2 coils. And you can see that I'm not getting anything across these 2. Again, I'm not really worried about this bottom one. Yet, on this one, look at this. I am getting a reading of 221 ohms, which is what I expect across this coil. So this one for sure is completely burnt up. And so what happens is inside these guys, you essentially have a tube, which is a ferrous material like iron or steel. You have a wire running all the way around this tube and out. And these are your 2 pins. So this is your positive and your negative terminal, not your ground. Your ground is the other one. And if I were to go in here and break those wires, now I have an overload, which is what I was reading on this multimeter, and we're not getting any current through, therefore no magnet. The other thing that can happen is a little bit less frequent, but it does happen where some of the insulation on these wires will go bad, and now you essentially end up getting a connection across the 2 terminals that you're not supposed to. If you read and you get 0 ohms, not overloaded, you actually have a short. And so that, again, I'm calling it a burnt coil just because it's easier for customers to understand. But a burnt coil means that you're either getting overload or a short, and this thing is bad. Unfortunately, you can't really open these up. The only thing you can do is simply replace it. So, simple enough, I hope. Failure point number 3 and 4 both have to do with the nucleus. The first one is your seal. Like I said, this is a very old machine, because you can see there's actually damage on that nucleus seal. I do not like these ones that use rubber gaskets. You're going to see a lot of people talk about, I believe it's ruby nucleuses. And in that, you have, instead of rubber, you have a flat mating surface that's going to go down and hit, and this will also have a spring force. But if you take it apart and you realize that whatever this is cracked, damaged, or otherwise not good, and you're getting dripping usually through the system whenever you're not supposed to, your nucleus is bad. And then the last thing, and this happens if you don't have good water, you're going to take this thing apart, and this thing is going to be stiff. You cannot move it. Normally, it should slide very freely like that, and it'll either be stuck open or stuck closed. That is usually a scale buildup. You really need to get your water checked out. But those are really the 4 points. So this last one was just we're going to call it a jam. So first one, you can have debris making the seal with the gateway there, bad. The second one is your solenoid coil is bad, and you can usually check that just by going across the two terminals. The third is that the nucleus itself is damaged and it's no longer good. Or the fourth is that this thing is not moving freely. Now, honorable mention 5. You go through and you check all of these, and you're like, none of them are the problem. Usually it's upstream. And in this case, you need to check your wiring. This is a lot more dangerous. I typically recommend you leave this to professionals once you get to this point. You're usually going to have to turn your machine on, actuate whatever button would normally turn this solenoid coil on, and then using your multimeter on a voltage setting, you're going to see if you're actually getting voltage across that terminal where you're supposed to be. So making sure you're actually getting power to these terminals. And you're probably going to find it's either low power or no power, which is a nightmare to chase, and that is what it is. Now, I hope that you're looking at this and you're thinking to yourself, man, that actually isn't that complicated. And guess what? It's not. These are not complicated devices at all. Again, with your three-way, you get a little more complicated because if this is your inlet, you're on a two-way, it's just trying to make a channel and a flow path through. And on a three-way, whenever it turns off, you now have a backwards flow path out. But it's simple. Basically, I turn on a magnet. Wrong way. I turn on the magnet. It lifts the nucleus up. You get water through the system. Whenever I turn off the magnet, the nucleus ends up falling back down and sealing the system. It's really simple. A lot of times, these are actually extremely reliable devices. This one burnt up, which it was a really weird error that I hardly ever see. You can see this guide here is also all rusted up. This had actually developed a pinhole leak here towards the base, was spewing water all over the actual solenoid controller like this. And so it fried the inside along with having a pinhole leak. So I ended up replacing this whole thing. A lot of times though, you can take it apart, and this one's a little bit of a different design. Your spring is here on the top rather than at the bottom. You can see how bad this one got. And it also had a rubber seal that I didn't like. But a lot of times, what ends up going bad isn't your coil, but something on the inside, where you either get a bunch of bad debris here on the inlet and the outlet, and this one isn't terrible. You end up getting a failed nucleus seal, or you get a jam. If you take these things apart and put it in a citric acid bath like this one, that will end up cleaning all of it up for you. This is just your normal descaling solution, and I don't know how quick this is going to work. It's a pretty simple way to clean these guys. So little citric acid bath just for a few minutes. You can see how much that cleaned up. Again, not hard to service. This one was also really bad, and the same bath did this. My one recommendation, though, is get a multi-pack of O-rings, specifically the Viton, whatever. And whenever you open one of these up, go ahead and replace the O-ring outside seal. Just, it's good practice. It's going to save you from leaks, because you can get leaks from around the outside of this, and that's a good way to fry a lot of your electronics. So replace the O-rings while you're in there. If you're messing with a crush washer like that, multi-pack of crush washers, they're not expensive. Don't be silly. Go ahead and do the things right. This and this combined were like $20, and they'll last me for years. But the only expensive part is this guy. If this breaks, you're kind of out of luck. With a lot of the Nucleus, you can replace those. A lot of major manufacturers like La Marzocco have these readily available, including the Nucleus itself. Nicer nucleuses can be replaced, or nuclei can be replaced or rebuilt. The ones with these rubber seals, though, I always say just replace it if it goes bad. It's not worth the hassle of trying to put in a new seal. But again, they're so simple. I don't know why we have this mysticism around, oh, there's a box with a wire, I can't work on that. Yes, you stinking can. If you can get it off the machine, use some brake line wrenches to get these off, or even Nippics for all that matters, you can get this thing done. I cheat. This has saved so much trouble over the years. So I personally use an impact driver like that. You don't have to. If you're going to get an impact driver or really ever try to get these off, I do recommend longer sockets like this that can actually reach all the way down over. Otherwise, you're going to have a hard time, and you probably will strip this off because these are not very big. You need all, or like the width there is not very big. Usually you want as much grip as you can get. You're going to sit there and torque it, and you're going to move it, and it's just going to be frustrating for you. If you can, get it off of the machine first. That is my biggest tip. If you can, don't be testing this thing out while the machine is on. Turn this stinking machine off. Stop being dumb. I keep seeing that. Especially on a 220 or 240 volt machine, you are liable to get sincerely hurt if you are not smart about it. And there are hot wires, especially to that heating element. I see people opening up machines without taking safety precautions, having no idea what they're playing with. Turn the machine off, and not just turn it off, unplug the stinking thing because it still has power to it, or at least flip a breaker, and then start the process. But solenoid valves, super simple. Check for the failure point. Get a multimeter if you don't have it. If you are an at-home espresso enthusiast and you want to be working on these things, again, the way all this works is simple. It's simple math. Now, I'm going to do some math. A force. This is for springs specifically. F equals Kx, where K is your spring constant and X is your travel distance. The reason I'm getting into this is I didn't understand for the longest time how in the world does this stinking little spring prevent 9 bars of pressure going through the system? That, I think, lots and lots of pressure, like 120 psi versus little spring. Which one wins? Well, this is how it works. What you end up getting is this little plunger here making a seal. You can see this is an old one, and that little ring on the inside is where it's making a seal at about the size of 1 millimeter. And the pressure of water, or the force being applied to this, is, we're going to call this water force. Force, F, equals your pressure times your area. For anything in a circle, your area equals pi r squared, remember this, and your pressure equals whatever the inlet is. Normally for a water supply, you're looking at something like 3 bar, which we know, which is 300,000 newtons. And we know that the radius here is normally only about half a millimeter. We end up getting pi times 0.0005 squared. So our area is equal to 7.854 times 10 to the negative 7 meters squared. We have 300,000 newtons. So plugging our A and our P back into this equation here, force equals 300K times 7.854 times 10 to the negative 7th, which ends up getting us a total force of 0.263 newtons, which equals 0.053 pounds force, or roughly 24 grams of force is being applied to this guy whenever there is water pressure going in. Going back over to our spring constant, I don't really care. All I know is F equals K times X needs to be greater than 24 grams to get a good seal. 24 grams, as we all know in the coffee world, is not that much. So bringing this back in theory, we have 3 constraints. We have the pressure, we have the spring, and we have the magnet. To have a closed system, I need this pressure to be less than this spring, but to have an open system, I need this spring to be less than the magnet. So essentially, if we can apply more than 24 grams of magnet force to the solenoid nucleus, then we can open up the system. I hope that's enough nerding out for you. That's why it works out. Anyway, back to the drawing board. It's just an electromagnet like you might have seen at like a second grade science fair. Stop making it overcomplicated and take care of them. Make sure you service them. Don't just let them sit there and rot. That's all. Thank you very much. I hope that this is helpful. These things are awesome, and they're the reason why your espresso machine actually works. Without it, you have water all over the floor.